Well, there's not going to be much flying in this weather. So I thought I'd get back to the community by showing how I designed my own 3D printable replacement Cinewhoop ducts using Fusion 360. So my name's Ashton, and this is Striking FPV R&D, a little mini-series on drone development from an average tinkerer such as myself. Now, if you already know roughly what you're doing and you just want to skip ahead, I have time-stamped the video. And if you just want STL files, I've also included them down in the video description. So without any further ado, let's get started. All right, so you got to start up Fusion 360 first. Now here's the thing, Fusion 360 is free, and I'm not teaching you how to install it because it's pretty self-explanatory. But you do have to sign up, click a couple of boxes, and once you're ready to go, you'll be presented with this screen. Untitled document. So first things first, we need to create a sketch by clicking this button on the top left. A sketch is basically a 2D drawing that we're going to use to end up with a 3D object. So first things first, I need to choose a plane, and I'm not going to choose the top-down plane because despite this being a circular shape, and you're thinking maybe I want to draw a circular shape like that, we're not going to do that. We're actually going to draw the cross-section of the shape. So we're going to select this side plane, could be the other side plane, as long as it's not the top-down one. And we're presented with this grid. So first things first, how big do I want the duct to be? So what I'll do, I will take the original Cloud-149 drone, 149 HD in this case, and using a pair of calipers, we're going to measure the diameter. And that is almost exactly 80 millimeters across. But I know that that's a little bit too much. If you look, there's a little bit of extra gap around the props, and if you want really good efficiency, you want that gap to be smaller. So if I quickly measure that gap, and I'm just eyeballing it, it is actually about 3 millimeters. Spoiler alert, I've actually done this before. I've made a duct before, and the amount that I actually quite enjoyed using was 78 millimeters for these props. You could go smaller if you had slightly smaller props, but that's completely up to you and part of the prototyping process. So, if 78 millimeters is the diameter, I actually need to work with the radius, which is going to be 39 millimeters. So, click on here, this is the line tool. It's how you draw lines. You'll notice a pop-up appears. All of the tools up here have a little pop-up which explains roughly what they do. Very handy. Once we click that, I'm going to click on the center of our sketch, and you'll notice if I move my mouse around, it's showing a preview of the line, including two things that I can fill in. The first text box that you see here will actually define the length of the line, and if I press tab, I can also select the angle that the line is from the horizontal plane, for example. In my case, I want to set the length of it, so I'm going to kind of move the mouse here where it locks to a horizontal plane, and I'm just going to type 39, press enter, and now I have the line at exactly 39 millimeters long from the origin. From that point, I'm then going to draw the rough cross-section of the duct that we want to create. So I'm going to click here, move the mouse up, and now I need to know how tall the duct is. So to save me some time, this is another duct that I made. I'm going to measure roughly with this, almost exactly 30 millimeters. So we're going to type in 30, press enter, there we go. Now in terms of thickness, the original duct is about it's just shy of 2 millimeters thick. I've actually made mine, also 2 millimeters thick. So we're going to type in 2 when we create this section here. So I'm going to zoom in a bit, use the scroll wheel on the mouse to zoom. Click on that point, draw across, and just type in 2. Then we're going to complete the shape by drawing down. And you'll notice it's still doing the line thing, so I'm going to click across. And there we go. We're pretty much done. Now the other thing is we have the original line that we used to set the initial distance. I'm going to just click on that and press delete. And now we're left with our main cross section. So just to demonstrate, We click Finish Sketch. I can then use the View Cube to go back to a kind of 3D view. I like to use this top kind of oblique angle. Zoom out a bit, and with this section selected, this sketch selected, like so, I then click on Revolve. And Revolve, what it's going to do, it's going to sweep around, basically, and create the cross-section around an axis, which I now need to select. In this case, the vertical one, the blue one. So we click, and boom. Now you see how this tool happens to work. It's created, I'm going to click OK, it's created a revolution of our cross-section and generated this, what actually looks a bit like a brass sleeve. But this is not really a duct shape. So what we're going to do is we're going to go back into the original sketch and modify it. And that's the brilliant thing about parametric design and software like this, is that you can actually go to a previous step, change it, and alter the outcome of the final piece. So to do that, we're going to go to this little timeline on the bottom here, and I'm going to double click on the sketch, and it brings me back to the sketch. So what we need to do is now create a rough duct kind of shape. Now, with the knowledge that I plan to print this upside down, you'll know if you have any experience in 3D printing, 45-degree angles are roughly the limit that you want for overhangs for when it prints kind of off the bed. So I'm going to use that as a guide for creating this particular duct. So let's use the line tool, and I'm going to zoom in over here, click on the top right edge, and it's not locking, which is a bit annoying. There we go, now it is. And there we go, so that's the first kind of edge. Now I want to have a lip, so I'm going to click there. Again, let's type in 2. So 2 millimeters out, and then we'll have the rest of the lip also kind of 45-degree thing going on. Click, and then back to the main part. Now here's the weird thing. I have this long line here where I don't want this section, and I have this long line here where I don't want that section, nor this one. There's a handy tool for that, and that's called the trim tool up over here. It looks like a pair of scissors. With this tool, it will know where any lines have intersected and give you the option of trimming those lines. So by clicking on these areas, I get to remove those lines. If I click Finish Sketch, now our duct, let's go look at a 3D view, looks a lot more like a duct. To further refine this, I'm going to go back in, and there's another thing we can do. So I don't really like this sharp edge over here, but knowing what I know about overhangs, I can actually make this smoother. So using this tool here, the Fillet tool, I can click on that corner, leave it at 1, or I could make it much larger, make it 2. Maybe that's better for strength, so let's do that, 2. And now we've made this nice and smooth curve. And again, with the overhangs, I can't really do that with this corner because that's going to cause issues with the print, nor with this one, but I can do it with this. So I'm going to click that, and it's automatically selected 0.5. I wanted a bit more than that. Let's try 5. Oh, maybe too much. Or maybe too little. 2.5 then. 2.5, now let's just go with 2. Press OK, or press Enter, sorry. And now our duct has an even smoother shape. Once we click Finish Sketch, now it's looking even more like a vaguely aerodynamic duct kind of shape. So there we go. That's our basic duct design. Like, comment, subscribe, blah, 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 blah. See you next time. No. Okay. Not done yet. Now we need the mounting points. So once again, where's my sample duct? The interesting thing about the Cloud-149, and I believe there's another type of drone, I'll mention it in the comments, I can't remember it right now, but it uses a 3-bolt or 3-screw kind of mounting system. And whilst it's going to be relatively easy to deal with that, these two might be a little bit odd in terms of placement. So it helps if you have the original frame of the drone like this, so that you can take hard measurements of the mounting points. This is a Cloud-149 frame, the original one, I'm currently flying a Cloud-149 HD because I have a DJI Air unit. But I originally had all that equipment in this, and so I've got this frame kind of left over. So what we can do is use this with the calipers to measure the distance, the center to center distance from the motor, or the prop or whatever, the center of the duct to the outside mounting point. And through some clever little assumptions, we'll also be able to work out the exact positions of these two as well. So if we take the calipers, stick them in here, like so, and give it a little bit of a jiggle to settle it in, we are at 43.5. But you'll notice that I'm measuring the outside edge to the outside edge, which is not center to center. So how do we work that out? Well, 43.5 is the outside to outside. The actual center to center is halfway back here and halfway back there. So all we need to do is measure the size of these holes. This one is 5.5 and this one is 2. So 43.5, let's go to our calculator. 43.5, we need to remove the the radii of the other holes that we just measured. So 43.5 minus, the small one was 2 millimeters diameter, which means minus 1 millimeter. And the larger one was 5.5, and half of that is 2.75, so minus 2.75. 39.75. So now we know that the center to center distance between the motor hole and the outside mounting hole is 39.75. And with this, we will now be able to create the mounting points in Fusion 360. So back in Fusion 360, what I'm going to do is I'm going to click over here. There's a little eye next to the bodies folder. Bodies are the objects that we end up creating. And I don't need to see this at the moment. So I'm going to click on the eye and hide it. Now, if I click off, you'll notice it's completely disappeared. Then we're going to create a new sketch, and this time we will be creating the sketch on the ground plane, the flat plane. And so here we are again, but this time we're looking top down. So what did I say earlier? I said earlier 39.75. So a couple ways we can approach this. I could just create a circle to begin with, and it's asking me for a diameter. So conveniently, 39.75 is the radius, but I need diameter, and simply multiply by 2. So I can type multiplied by 2, that's the asterisk on the numpad, and it will do that calculation for me. And you can do this in Fusion 360. You can type a small formula into a length or an angle or whatever text box, and it will do that calculation for you so that you don't have to think too much. So 79.5 is the diameter. Now we're going to place our top mounting hole. And all you have to do is move the mouse up there. It should snap. And once again, I can freehand set the size of it, or I can type in 2, because that's the diameter of the mounting hole. Except I need the screw to bite into the plastic, because I don't have brass standoffs. So actually I need this to be a little bit smaller so that the screw can bite into it, right? So now that we have a dimension actually shown here, this little 2, I can double click that and modify the dimension afterwards as well. So 2, we're going to set it to 1.7, which makes it just a little bit smaller, and it should give enough meat for the screw to bite into and hold on to the part. Now the second aspect is, what about the outside? So what I'll do here is, using the calipers, I'll just measure the approximate thickness of the arm itself, which is 7. And I think that's probably going to be an appropriate size for the standoff. So in this case, I'm going to click on the circle tool again, click on the center of that, and I'm just going to type 7. And there we have our standoff. But that's only the single one. What about the other side? Well, we'll work this out. When I say clever assumptions earlier, I mean, we can fairly assume that whoever designed this, whoever designed the duct, has made these, equal. They're basically symmetrical. Along this line, this is going to be a certain distance that way. It's going to be the same distance the other way. So all I need to do really is measure the center-to-center distance between these two holes. Now these two holes are the same size. They're also 2 millimeter. So here, the measurement is 17 minus the 2 radii of the holes is -2, which means the center-to-center distance is 15. So with that knowledge, I'm going to create anywhere. You'll notice that when I'm about to create a thing, create a circle or draw a line, the snap function allows me to follow the exact circumference of this circle. So I'm not going to be particularly careful about how I do this. I'm just going to choose somewhere roughly, type in 1.7 for the actual bolt hole, screw hole, and drawing there again, I'm going to type in 7, and we're going to do the exact same thing on the opposite side. And just to kind of prove a point, I'm going to draw that like way out of place, 1.7, and make one more that is 7. And now we're going to use the dimension tool to actually set where they're going to be. So this is the dimension tool. This allows us to add dimensions, lengths and distances between objects in order to constrain them in that kind of way. So for example, I now know that these two holes are supposed to be 15 millimeters apart, center to center. So what I'm going to do is I'm going to click on one of them and then click on the other, and it's going to bring up this little weird behaving kind of ruler thing. So if I set it like this, it's going to make sure that they're 15 millimeters apart horizontally. If I set it like this, it's going to be straight line distance, the shortest distance. And if I set it like this, it's going to be vertically. In my case, it doesn't actually matter too much, but I'm just going to demonstrate and set this to be direct straight line distance. Type in 15, and they suddenly pull themselves together, but they're both still on the circumference of our circle. In fact, if I drag one of them, you will notice that they're both staying on the circle and they're both staying 15 millimeters apart, which is really cool. But how do I get them centered? Well, even simpler. All I have to do is click dimension, select one, and then select the center of the sketch, because that's the middle. And once again, if I move it here, it's the straight line distance, but if I move it up there, I set the horizontal distance, and here I can set it to 7.5. And that sets the correct position. Or we can undo that, and just to demonstrate one more time, I can click here, click there again, and if my mathematics is really bad, 15 divided by 2, also 7.5. And now they're both the correct distance and the correct position. Anyway, there you have it. So now the only thing left to do is to get rid of the main circle, just by clicking and deleting it. And now we're left with our standoff. So let's finish the sketch, and we're left with the standoffs here. And before we actually introduce the main body back, what I'm going to do is I'm going to use this opportunity to select, and there's a reason why I'm doing this, but I'm going to select both the inside and the outside. I will show you this later. Sometimes it's a bit finicky. Come on, click. A bit finicky to select them for, I'm not sure what the reason is. If you know the reason, because you're a professional Fusion 360 user, please let me know. Once you've got all of them selected, we can go to one of our fancy oblique views here. And before we do anything, I'm going to unhide the main body, like so, which shows this, and we're going to press Extrude. And this is where the magic happens, because Extrude is a function that is used probably a lot more commonly than Revolve, at least in my experience, my limited experience. What we can do is we can drag the arrow up, and oh, it's done a red thing. If I drag it down, it's creating. If I drag it up, it's deleting, which is not the behavior we want. But actually that's very easily changed, because in this little window on the side, the extrude window, there's the operation drop-down box, and currently it's set to cut, and it automatically changes. If I drag it down, it now says join. I drag it up, it says cut. But if I select it, I can set it myself, set it to join, and now we've got roughly the design we want. Only thing left to do is decide the height, and the way we can do that is either measure one that I did earlier and find out that it's 10. It's quite tall. What about the original? If I use this, I can measure the original design's height, and their standoffs are 8. I kind of like that, so let's go with 8. I'm going to type 8 in this box there. That sets it to 8. Press enter, and now we've got our standoffs. And the only thing left to do is to make the actual holes. So let's go down to this view. Now you'll notice that the sketch that we had earlier that had the holes there already is now gone. But it's not, because if you go to the sketches folder here, we have sketch 1 and sketch 2. And if we mouse over them, it'll actually show you what they look like. I'm going to click the now faint eyeball, and that's going to reveal it again. And now I'll be able to zoom in, select that hole, select it over there as well. You hold shift, by the way, to select multiple things, if I didn't mention that earlier. And then you press extrude, and lo and behold, it's remembered the last time we did an extrusion at a distance of 8, but it's also setting it to cut again, which is fine. Now, how deep do we want these holes? Well, I'll tell you. The bolt itself, the screw itself, is not very big, actually. So, using the calipers to roughly eyeball it, it is just shy of 6 millimeters. The base plate that it's going through is 3. So the screw is only going to go up into the plastic by about 3 millimeters. But just to be safe, because 3D printers tend to over-extrude a little bit if you want better adhesion, we're going to set that hole depth to 4. And just like so, click OK. I can now hide the sketch that we just unhid, and we've got our holes. Now, for all intents and purposes, this is our finished duct. So, while we're here, Control S, Command S if they have Fusion 360 on Macs, I'm not sure, or click the floppy disk and choose a location. I already have quite a few folders available. I'm going to put this in the Cloud-149 mods folder and name it Full Duct. Press Save, and now we have Full Duct version 0. So now this is kind of our finished duct. I could just right click, Save as Mesh, select STL, click OK, and have the final design ready. But we're not actually done. There are a couple other things I want to consider. Have you ever noticed that on these drone frames, these carbon fiber sheet frames, that there are no sharp edges? They're all smooth. They're either circles or they're filleted shapes. That's because sharp edges, not so much sharp edges, but corners, sharp points, are usually points that focus stress and are more likely to break than if you had something smooth. Same thing with plastic. And what I'm noticing on this is that we've actually got a couple sharp points here related to the standoffs. I'd like to smooth these, so I'm going to zoom in here and select these sharp edges. And using our view cube to move around, we're going to select all of them. On the other side as well, here we go, click, click, clickety, click, click. And with all of them selected, now we can use the fillet tool, which is pretty much the same as the one when you're sketching. And once I click this, I then get to pull this out and actually set it. Now if I pull it out too far, it throws an error. But if I keep it relatively small, it's fine. And we can once again type in the exact amount that we want. So in this case, 3 looks smooth enough, so I'm going to click OK. And we'll do the exact same thing to the ones on the inside. Let's go around here. Remember, hold Shift to select multiple. Almost done. And once again, press fillet, and 3 seemed like a nice number from earlier. This one maybe could even do 4. Yeah, let's do 4. Click OK, and now it's smooth. But there's still something not quite right. The top edge is obviously a sharp edge. Not only that, but with the knowledge that I plan to print this upside down for the purposes of 3D printing, these become overhangs, and 3D printers are famously bad at printing in midair. So we need to sort them out as well, in terms of both smoothing as well as printability. So what we're going to do here is, looking at this edge, I'm going to select that edge, we'll zoom out, rotate around, again hold shift to select the other 2 of the outside, and now we're going to use not fillet, because the fillet will create, it'll lessen, but it'll still have an overhang. We're going to click on this drop down here on the modify thing, and it's going to give us more functions that are not normally up there, including chamfer. And at this point I could just drag it out again, but I'm not going to do that. I'm just going to type in the number that I think makes sense. So let's start with 2. Hey, almost. But you'll notice that there's still this kind of edge there. So with that, let's see what happens if I put in 3. Oh, you get an error again. And this is something that you've got to think about when you are using chamfer or fillet or other tools. There are limits to how far it can do something before it throws an error. So obviously 3 is too much. Let's go back to 2. I only need a little bit more, so I'm going to try 2.2. Oh, 2.3. And fail. So 2.2, what about 2.5? Nope. 2.49. 2.49 works. And you can still see that there's probably a little bit of a flat lip there. But it's so small that you pretty much can't tell, and the 3D printer won't have to deal with it anyway, because for all intents and purposes, that's a nice 45-degree angle up. So I'm going to click OK. If we go to our left view, you can now see that we have this nice 45-degree angle going into the duct. So that actually helps in terms of making it a strong, kind of solid, smooth piece without any focused stress points, and it's gonna be able to print. So all we gotta do is the same thing for the inside edges here. So hold shift to select multiple, spin around to get to that side, click modify, click chamfer, and once again, let's try 2 again. 2 is pretty good. 2.4, 2.5, 2.6, 2.7, 2.8. 2.8 too far, so 2.75, 74, 2.74, that works. Click OK, and now we have nice standoffs for our mounting points. Oh, but there's one more thing. Notice this, on one of my earlier designs, I have a little notch here, a little gap, because where are the motor wires going to go? Hooray! So actually, if we were to mount this particular design directly on the drone, we would crush the motor wires, or we'd have to make the motor wires go on the bottom side, which is no bueno. So what I'm actually going to do is find out how thick the motor wires are by using the calipers in a weird way again, using the bottom. And they are 1.5, which doesn't satisfy me. What if I want to put tape? What if I want to add extra protection? So let's pretend they're about 3 millimeters thick. Now we need to make ourselves a little tunnel. So how do we do that? Well, it's back to the sketch tool. So I'm going to click sketch, and instead of creating a sketch on any plane, I'm going to create a sketch directly on the bottom of our duct, like so. Now let's examine this. I need this to be relatively easy. So if I click here, you'll notice that this is the line design, and then this is the point where the fillet was created. So that seems like, to me, a wide enough thing. I mean, each of the wires are, what? They're about we know they're 1.5, there's 3 of them. So 3, 4.5, so I just need to make sure that that line is approximately, let's say 5, and if I draw a line, you'll see there that it's about 6, whatever, so it's long enough. Press escape to exit that. Click here to check the position again. What I'm going to do now is create a shape that kind of cuts into here. And the easiest way to do that is to click on the line tool, find the joining point there, and find a matching point on here, except there isn't really a convenient one there to choose. I could go straight down, that also works. But if you want it to be, perpendicular to the tangent of the circle, that's getting very complex. I just want it to be kind of straight with the curve like that. I'm actually going to zoom out and just click on the very center of where the motor is. And with the line still drawing, I'm now going to zoom in again and select the exact opposite point. And like that, we're done. Press escape, and you'll notice I now have a clickable section because it knows the outline of the bottom of the duct, and it knows the lines that I've drawn, such that I don't even need to get rid of these. But to be neat, I'll actually get rid of them. So we click the trim tool and just trim that part of the line, trim this part of the line, and now we are left with just that section. Click Finish Sketch, and using our view cube, we'll kind of angle ourselves back out to a position that looks kind of nice. And we're going to click once again, Extrude. And oh, it's extruded the wrong way. But no worries, drag it straight up, and it's extruding the correct way. So I could make this channel really, really big. There's no need for that. I'm going to set it to what I thought before. Let's say -3 was going to be roughly the height of the motor wires. Click OK, and we have a nice channel. Except for one thing. Sharp edges, which I don't like. So once again, angle ourselves, click on the sharp edge we don't want, rotate to the other side, hold shift, select the other one, and once again use the fillet tool. And we can drag this out just to get a feeling of what we want. I can look at the front view, see like how much of a mouse hole, kind of Tom and Jerry shaped mouse hole I want. I can even go even further and really close it, but I don't need that much, so let's just set it to 2. Click OK, and like so, we have a nice little channel for our motor wires. Now at this point, I would say I'm done, so I'm going to save first, Control S, or the floppy disk up there. So you'll notice that after it's finished saving, Fusion 360 has now determined that this is version 2 of our duct design. Whenever you make a lot of changes and save a lot, it's gonna keep iterating that number, so I actually have quite a few things open that are like version 14 because of changes that I've made. Now the only thing left to do at this point is to export the final 3D printing friendly file, the STL file. So, as I briefly mentioned earlier, we're going to right-click on Body 1, Save as Mesh, and it's new to Fusion 360, they didn't have this before. 3MF is a format, I'm not sure what that is, so I'm going to ignore it. I'm going to set it to STL binary, because that's what's usually been used. Unit type to millimeter, because I've been working in millimeters. And there's a thing here called refinement, which is set to high, medium, low. That's about the mesh, so to kind of give you an idea how that works, let's set it to low and check this box, Preview Mesh. And what that's going to do, it's going to show us the wireframe of the model that it's going to pump out. And this is what's going to be interpreted by your slicer program. Now, this is not super high resolution, and you may find that if you print this, you'll get faceted edges around. So what I'm going to do is I'm going to select high, and it's going to give you a preview and see how much more dense the wireframe is. And in general, this is a good idea, just to have it as high resolution as possible. I mean, you can go custom and set it to higher, but for this particular model, this is totally fine. Click OK, and it's going to ask you to save it somewhere. So I've already got one file here that I actually don't want anymore, so I'm going to call it full duct. Click Save, click Yes, and we're done. Only thing left to do is to drag it into a slicer of some description. So I'm going to do that. Prusa Slicer is my weapon of choice. It's free, and it's better than the original slicer because of all the extra handy-dandy little features. Not that the original slicer doesn't have all the features, Prusa has just decided to put it in more convenient areas. So I'm going to click Add, and we're going to select Full Duct. That's going to plonk it in our workspace, and as I mentioned earlier, this needs to print upside down, so using this tool here, the Place on Face, select roughly the top face, and it flips it upside down, then just click Slice Now. Obviously, use the settings that work for your printer. I'm not here to teach you about that, but once it's finished slicing, we can then preview our design and see how it's going to be built up. And if we zoom in like so, you can see roughly how it works, how it starts small because that's the original, first flat surface, and then it expands upwards at a 45-degree angle, which printers can do. And you can see the shape, the smoothness of the shape build upwards. And at a certain point, we'll even see, where are they? Where are they? There they are. We'll see where our standoffs start to appear. Let's zoom in even more because that's quite satisfying. There we go. Our standoffs appear when the hole for the bolt appears and how it finishes it off. That's it. Export your G-code, full plate G-code, click Save, send it to your printer, and hope it works. Now here's the thing. You're gonna have to maybe go through a couple designs because depending on how things went, you might find that your original design is too thick, too heavy, or that your printer settings were terrible. But after quite a bit of testing, I managed to get this level of quality. It's got a little bit of roughness on here because of some retraction settings I didn't set up properly. But overall, this is actually a really nice design. But, and I'll save this for the next video if you're interested, my real interest was designing a slammed duct like this. And I've seen other slam duct designs which are basically, half of this with just these standoffs sticking down. But I find that type of design is not particularly strong, which is why I created this, where the standoffs are there and they look like they stick straight down. But I've actually created this smooth surface there. Now if you can guess how I did that, then you probably don't need to watch the next video. But if you'd like to see how I made this, then please let me know, because I think that would be a nice little next video to do, just to kind of elaborate on duct design in general, as well as for 3D printing, because there are some nuances. If you want to avoid using supports and stuff, how do you design it so that it prints in one go and prints really nicely? I've kind of, pulled that off. I'm sure other people have too, but the point is I'm showing you. So let me know if you want to see that. Anyway, thanks for watching. Let me know if I missed anything. If you're a real Fusion 360 user or you do it professionally and I've missed something or I'm using the software incorrectly, bad practices, best practices, feel free to let me know. I'd be very curious to find out because, I'm only self-taught in this regard. But the fact that I am self-taught does say a lot about the state of CAD design software, Fusion 360, and how relatively easy it is to learn. So if you are a DIY kind of person, you've gotten into building drones and you've got a 3D printer and you're constantly searching for STL files everywhere, maybe you might want to actually create your own STL files. And that's what this is about. So yeah, thumbs up if you liked it, thumbs down if you disliked it, please know. But yeah, comment if you want to see anything in the future, or if you've got any advice for me, and subscribe if you think this was really worth it. This is my way of giving back to the community somewhat. I've tried to do that in all the things that I've kind of taken up as a hobby, so yeah, hope it works out. See you later.